Today we are going to discuss about the string algorithms. String algorithms are fundamental tools in computer science, forming the backbone of the countless applications that process textual data. These algorithms are designed to efficiently manipulate and analyze sequences of characters, enabling us to perform complex operations on text, speed, and precision. These are mainly used in search engines, text editors, DNA sequence analysis, and plagiarism detection. So by the end of this video, what you will understand what a string algorithm is, what pattern matching means, the formal definition of the substring search problem, the key terminologies such as text pattern and match, and finally we will analyze the naive string search problem with its time complexity. Stream processing is fundamental in areas such as I told the DNA's sequence analysis like that. So today we are going to first we understood the definition. Next we'll go to pattern matching, substring search, naive algorithm, and the complexity analysis. So what is a string? Before we are going to discuss algorithms, let us find what a string in formal form. In computer science, we define alphabet usually uh, denoted by sigma, like this. Alphabet in the sigma sign is not denoted as the algorithm. Algorithm is a finite set of characteristics. String is also known as the finite sequence characters from the alphabet. String is the finite sequence of characters from the alphabet. So, if for alphabet, so if for alphabet is A, B, C, so then our valid strings are A, B, the next is C, A, B, and B, C, A. These are valid strings. So, a string algorithms is simply an algorithm that performs operations on strings. The substring search problem. The substring search problem is a core task in string processing. It involves identifying whether a smaller sequence of characters exists within a large sequence, the text. The problem has wide-ranging applications from simple text editing functions to complex dynamic processes. Like we are given two strings, like uh, think of uh, text t of length 10 and pattern p of length m. The text is larger string in which we search. The pattern is the smaller string we are trying to find. So initially this is t equals t 0 n minus 1 and the pattern p 0 m minus 1. The problem is to determine whether p occurs inside the text, like in the t. Now write the formal condition, like match at the index match at the index if t is T plus T index plus J equal P, like this. This means that starting from one some index in the text, every character of the pattern must match exactly. Key terminal is like text is the largest string, pattern is the string being searched, and the match is the exact occurrence of the pattern in text. As an example, T equal A B R A C A D B B A, like this. And up pattern of the P is the C A D A. So we'll write the index positions. Index of the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the T is A, B, R, A, C, A, B, E, A. So this is our index and the T. We check the pattern that appears in the text and align visually. So then we'll gain the CADA. At index 4, every character matches. Therefore, we say there is a match at index 4. Like that, we are getting it. So naive string search algorithm. In this, the naive search algorithm is the most straightforward approach to find occurrences of a path with of a pattern within a text. It operates by system checking every possible alignment of the pattern against the text. So it is called like naive because it checks every possible alignment. As I get the pseudocode, the it begins by aligning the pattern with the very beginning of the text. It then compares the characters from the pattern with corresponding characters the text from one to the right. So if all the characters a match is reported at the current alignment starting index. If a mismatch is found at any point, the algorithm shifts the pattern one to the right in the text and restarts the character comparison procedure from beginning of the pattern. This process continues until the pattern has been shifted past all possible starting position in the text. The outer loop shifts the pattern across the text. The inner loop compares characters one by one. So if we get as an example, uh, we'll get this. Now, so step 1, I equals 0. We have to align it. So A equals A, B equals B, A equals A. So the pattern matches. So all characters match found at index is 0. Step 2, index equal 1. So we'll move this B and the index is 1 because every starting point in first integer is getting the index 0. B does not equal to A. So index equal 2, then we are moving this again. So A equals A does not equal B. Can you explain that? Like it keeps shifting until I equal n minus m. N minus m means 8 minus 3 equals to 5. And then this algorithm checks every possible starting position. So like we'll get this to the 5 like that. So nextly, time complexity analysis. Analyzing the complexity of an algorithm helps us understand how it performs with the size of its inputs. For nice string algorithm, both time and space complexity are important considerations. Time complexity, the inner loops iterates n minus m plus 1, representing each possible starting position for pattern in the text. The inner loop performs character comparisons. In worst case scenario, this inner loop runs up to m times for each iteration of the outer loop. This leads to the worst case time complexity. This occurs when the algorithm performs nearly all m comparisons. So like outer loop runs n minus m plus 1 times. So inner loop runs at the most of the m comparisons. So the worst case possible is like this. So at every shift, the first four characters match. The mismatch happens at only the last character. So for the alignment, we perform nearly m comparisons. So the worst case complexity it is getting like this. This is how the worst case complexity is getting. Space complexity is O times 1 because we only use p variables. Space complexity equals to 0, 1. So this is the time space complexity. Edge cases and the conclusion is like uh, if if m is larger than the n, no mismatch is possible. If pattern is empty, the trivial match is the multiple matches may exist in this string algorithms. So we'll summarize this.